Ladies and gentlemen, boys and girls, welcome to another math video. Today's topic, we're going to be talking about synthetic division. All right, we talked about polynomial long division yesterday, and synthetic division is a way that we can do a specific case of that types of division more quickly. So, let's take a look at what we need in order to do this, in order to actually do the synthetic division process. So in order to use polynomial division, or synthetic division, we need two things. First, we need that polynomial to be in standard form with zeros as placeholders for missing terms. Just like we did with polynomial division, we needed those zeros as placeholders for those missing terms, so that's no different. It needs to be in standard form, and it needs to be a polynomial. All right, we can't have any fractions in our exponents or anything like that. It needs to be whole number integer exponents. Okay, and the thing that we are dividing by, the second thing that we need, the thing that we're dividing by needs to be of the form x plus or minus a. So x by itself with nothing in front plus or minus some number. Okay, so for example, a problem that we could use this for would be something like this: 4x squared minus 12x plus 9 divided by the quantity x plus 1/2. Okay, so this meets both of those criteria. We have our standard form, and we don't have any missing terms. We don't have any missing exponents, so we don't need any zeros. And we have our divisor. The thing we're dividing by is x plus or minus some number. Okay, so now we need to figure out a way to set this up. Every single time we set one of these up, we're going to do three things. First, we're going to have a little box. Okay, make just a little bracket here, and then give yourself a little bit of space, and make a horizontal line. Think about this as like your equal line for addition and subtraction, that sort of thing, and multiplication. Okay. Third thing is going to come later, but we'll talk about what that is when it happens. Okay, so we want to put some number in this box. We want to put some number in this box, and that number is going to be the opposite of whatever number is in here. Or, if you want to think about it this way, we want to ask the question, what number could I plug into the thing I'm dividing by to make that thing 0? In this case, it's in most cases, I can't think of an exception. What number would we plug in to make this thing 0? Well, since we're adding 1/2 to x, if we make a negative 1/2 for x, that'll make that parentheses 0. So that goes in that box up there. The next things we're going to write down are going to be all of the coefficients, or all of the numbers in front of all of the variables. Okay, so all of the numbers that show up: 4, negative 12, positive 9. Okay, if there are any zeros up here, we would just write down a 0 wherever it lives. But in this case, we don't have that. All right. So then we go through a process. We go through a system of steps that will get us to our answer. Okay. So the way we do this is the first number always just comes straight down. We just bring that down, and it stays the same. It doesn't change. Then we're going to take this number times the number in the box, and the number below the line times the number in the box, and that number we're going to write over here. So 4, that number we're going to write underneath this negative 12. We're going to write our new number right here. So 4 times negative 1/2 is negative 2. Once we have this number here, we're then going to add these two numbers together. We're going to add these two numbers together and get negative. That's completely not correct. We're going to get negative 14. We're going to add those two numbers together to get negative 14. Then we're going to take negative 1/2 times negative 14 and get positive 7. 1/2, negative 1/2 times negative 14 gave us positive 7. Negative times negative is positive. 1/2 times 14 is 7. 9 plus 7, in this case, is 16. So cool, we got some numbers. Okay, but what do those numbers actually mean? So in order to check that out, in order to figure out what they actually mean, let me slide this over a little bit, and let me actually do the division problem for you. Let's do the division problem. So we have 4x squared minus 12x plus 9, and then we're dividing by x plus 1/2. Again, we need 4x times x will give us 4x squared. So 4x times x is 4x squared. 4x times 1/2 is 2x. Then we're going to subtract this parentheses. So 4x minus 4x, those are going to cancel out. 12x minus 2 more x's is negative 14 x's. We bring our 9 down, and we get negative 14x plus 9. Then we say, what do we multiply x by to get to negative 14x? That's negative 14. And then, so negative 14 times x is negative 14x. Negative 14 times 1/2 is going to be negative 7. And then if we subtract this guy, 14x minus 14x, those go minus negative 14x. 9 minus negative 7, it's like adding, so that's going to give us 16. So we have 4x, since there's nothing left to bring down, 4x minus 14 is remainder 16. Okay? So that's where these numbers come from. The 4 is our 4x, our 14 is our negative, our negative 14 is our negative 14, and our 16 is our remainder. So we could take this number, this problem that we got here, and we could say, all right, this becomes 4x, this becomes minus 14, and then this is remainder 16. Sometimes I have seen people do something like this to add another little box on there. If you like to do that, if that'll help you set things up, that's fine. That's wonderful. Please do that. So that is our synthetic division process. Remember, zeros for placeholders. Anything else needs to go in there in the correct spot. So let me give you one to practice. So here you go. Give this one a shot. X to the fourth minus 2x cubed plus 3x plus 1 divided by x minus 3. Give that one a shot. See what you come up with. All right, welcome back. Hopefully this is what you came up with. X cubed minus x squared plus 3x plus 12 with a remainder of 37. Okay? So make sure that you're keeping track of these remainders. All right. Also super important, if you forgot it, make sure you have the placeholder for the x squared term that didn't show up in here. Okay. That guy needs to be a 0. Make sure you have that in there. The remainder is super duper 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 important. So I noticed in some of your homeworks that some of you would write this for your answer. But instead of writing it as remainder 37, you looked in your book, which is great. I appreciate you using your book. That's what it's there for. But you would have written something like this: plus 37 over x minus 3, which is fine. That's what your book says. That is technically not incorrect. But I would really prefer if you rewrite it as remainder 37. And we're going to go into why here in a little bit. So this should be your answer. X cubed minus x squared plus 3x plus 12, remainder 37. All right, so I'm going to give you some practice on that in your homework. So now, the reason we do this is because this is a really nice, quick, easy way for us to check function values at specific points, at specific x values. So, and we can do that by a theorem called the remainder theorem. Essentially, the remainder theorem says that if we have some function, we'll call that function p of x. Okay, just the name of our function. If we divide that function by x minus a, our remainder is going to be the function, whatever that function is, evaluated at whatever value a is. So, for example, let's say we had x cubed minus 4x squared plus 5x plus 1. And we were dividing this polynomial by x minus 3. All right, so the a value, this a number here, is always going to be the opposite of whatever number you see in parentheses here. So in this thing, a would be 3. So if we wanted to evaluate our function, at a is going to be x cubed, or we're going to take a and replace it with x. So we're going to say a cubed minus 4a squared plus 5a plus 1. And we could very easily plug in p of 3, which is 3 cubed minus 4 times 3 squared plus 5 times 3 plus 1. 3 cubed is 27. Let's see. 4 times 9. 4 times 9 is 36 plus 15 plus 1. So we get 27 plus 15, which is 42. 43 minus 36. So I'm thinking this should be in the neighborhood of 7. So we should get p of 3 equals 7. But that's a lot of arithmetic. That's a lot of mental gymnastics. That's a lot of math stuff that if we don't have to do that, it might be in our best interest to not do that. So let's see if we can use this synthetic division where we can say, all right, if I take this and I plug in a, so the value that makes this parenthesis 0, if I take that and plug that into my synthetic division problem, well, now if I grab the coefficients, so 1, -4, 5, and 1, and I do synthetic division with this, so this becomes 3. Nope, that's a lie. Just come straight down. This is a 1. 3 times 1 is 3. -4 plus 3 is 1. -1, excuse me. 3 times -1 is -3. 5 plus -3 is +2. 3 times 2 is 6. 1 plus 6 is 7. Remember that this guy right here is our remainder. So the remainder is our function value. This guy right here is our function value, p at a. So we can use this as a nice, quick, easy way to plug in a bunch of function values very, very quickly. Let's say there's a couple different ways that these problems can be presented. Like this, if you're given this parentheses, actually, you know what? Let me clear this off. So there are 3 ways that these types of problems can really be presented to you. So the first way is if they say here's a polynomial, divide it by whatever this thing is in parentheses. Okay, for that, in order to figure out what number is going to go inside your box, inside this little box up here that you're going to be using for your synthetic division, you're going to use the value that makes that parentheses of the thing you're dividing with. Use the value that makes that thing 0. Okay, so if it was like x plus 3, then you're going to, why would you do that? If you're going to use x plus 3, that means that a is going to be -3. Okay, so for scenario number 2, if you're given x just equals a number, then just use whatever that number is to go into the box. So if you're given something like x equals 3, that means that a is going to equal 3. Okay, and then similarly, same thing for, it says a lot of times you'll see a thing that says evaluate the function at some function value of x, or at some value of p of some number. Again, whatever that number is, just use that. So let's say we wanted to evaluate some function at 3. Then that means that a is going to be 3. And a is always going to be the number that is going to go in here. Okay? A is that number that we're going to start with. Okay? So make sure you keep track of that. I'm not sure what possesses people to give different sort of ways of asking the same problem. It just kind of stinks. Okay, so let's take a look at some stuff here. Let's take a look at an example. So let's say we wanted to find the value of a function when x equals 4, or we wanted to plug in 4 to our equation and find what the y value of that equation would be. All right. So if we do that, since we're given a 4 in that parentheses, we're evaluating that function at p of x equals at x equals 4. 4, it goes in our little box up here, and then we grab all of our coefficients: 1, -4, 3, and -5. From there, we do our synthetic division process, with our remainder going to live down here. So 1 lives down here. 4 times 1 is 4. Negative 4 plus 4 is going to be 0. 4 times 0 is 0. 3 plus 0 is 3. 4 times 3 is 12. And negative 5 plus 12 is going to be positive 7. So we are going to have our function p. If we evaluate that at x equals 4, that's going to be 7. Or we would be given the point, we would have the point 4, 7 from this particular problem. Okay, so that's what we're doing. That is synthetic division. You'll be using that today, and interesting things happen when our remainder is 0. If our remainder is 0, neat things happen. So we'll talk about what those are in the next section, in the next video. Until then, have a great one. I'll talk to you guys later. Bye-bye.